In this video, we are going to demonstrate the working of our minor project 1 titled Improving the Regularity of Transport Services in Rural Areas. First is the collab environment in which we are going to test the code, and later we will see the web application that will be developed using the same functionality. And here is the dataset that I already uploaded in the collab environment. Let us see the dataset. This is our dataset that we had directly acquired from the community service project through the Google Forms and by directly interacting with the people. And this dataset contains 200 observations related to the people transport. And the only feature we are going to schedule is preferred travel time that you can see here. You can ask why I am not taking other, because if you take other, it causes overfitting. By taking more features for the clustering, it definitely causes overfitting. So I am taking only this preferred travel time, which may result in better accuracy. So let us see the code. And here to implement our code, we are using several Python packages, and here the pandas for dealing with the dataset and reading the dataset, and sklearn is a popular package for machine learning algorithms. Preprocessing is for data preprocessing. Here we can see in our dataset this preferred travel time is in a string type, and I need to convert this string type into the date time type to facilitate the normal working of an algorithm, because any machine learning algorithm cannot take the string type. The string should be converted into the numerical type. So preprocessing is required, and a standard scaler to scale the values to a normal range. And as we are main methodologies using clustering algorithms, I had been using these two modules, sklearn.cluster and PyClustering, and we are using the metrics to evaluate the performance of our algorithm. Similarly, Matplotlib is to visualize the results. Here are the code that deal with the data preprocessing and the data intake. Here we are using the def. As we are in the dataset in Excel form, we are using the function read Excel to read the dataset. And as we know, preferred travel time is in a string type. I am converting it to the date time type. And here the scaling features, because if we not scale, it causes the outliers. And here are the two inputs. The other extra two inputs that we are taking is number of vehicles. Number of vehicles means the number of clusters to be formed, so this is an important feature. And the vehicle capacity means the maximum number of points that can be accommodated in a cluster. Like in case of an auto, it can accommodate a maximum of 6 people, like that vehicle capacity. And these are all the clustering algorithms defined using the variable clustering algorithms. We are using the algorithms k-means, minipatch, k-metoids, dbscan, and agglomerative clustering. We are using all the algorithms to have a better optimal algorithm, because some type of algorithms are suited for a small data set, some data algorithms are suited for sparse data sets. That's why we are using the many algorithms. And here Silhouette score is a matrix we are using that usually ranges from 0 to 1. The values near the 1 are more accurate, the values near the 0 are really less accurate. So here we apply the clustering algorithms, and you can also see some exception handling statements are being placed here to show exception when data is not according to the standards. So after all data is passed into the algorithms, they will cluster the results, and this cluster will be evaluated based on the Silhouette score to schedule the best optimal algorithm. Here you can see the code to plot the graph. We are plotting the scatter plot, and here are the labels. Let me execute this. Here you can see the first input is number of vehicles. Let me enter a 14 and enter the capacity of each vehicle. Let us take an example of auto. Maximum 6 people can be accommodated in it, so I'm entering 6. So here you can see the algorithm is calculated the silhouette score for each and every algorithm: k-means, mini-batch, k-metoids, db-scan, agglomerative clustering, and except mini batch all have similar silhouette score. But as a k-means is first, I'm selecting the k-means 0.98, and the clustering results, these are the points that represents the cluster center. Here you can see the labels like 4 means 4 o'clock, 6 o'clock, in 24-hour format 8 o'clock, like that. And you can see as it is near 3, it will be scheduled at 3 o'clock, like that. There will be 14 cluster centers, and nearly 14 clustering will be performed here. This is the demonstration of our code in Colab. We had made a web application that uses same functionality. Let me demonstrate that. uh, Let me go through this. I will show the files related. Here is the file that is web application, where I had stored all the files regarding our web application. Here you can see the survey data. I have stored this here, and this is the app. This is the Python application. We are using the Python called a Flask module, which is very useful to build web applications. And in static folder we had included the CSS and JavaScript, and templates folder we had included the HTML file. So let me run this. I'm executing the Python program using python app.py. It take quite a bit of time. Now you can see the instance is created running on HTTP web address. Let me use this web address, and it is running on the local system. Let me go to a web browser and enter the address. So this is a web application, this is the front end, and we had given the heading as transport scheduling. These are the 3 inputs. Let me give the data set, survey data, and the number of vehicles. Let us take different 13, and the capacity may be 5. And by clicking the schedule button, we can see all the vehicles are 13. I given number of clusters as 13 vehicles are 13 optimal times are being generated to schedule the vehicles. Let us also see the Python code. As I said earlier, we are using the Flask to run the web application, and here are some of the JavaScript containers we are using as similar functionality of the previous code in Colab. So this is our project on improving the regularity of transport services in rural areas using the clustering approach. We are doing this. So this is the architecture diagram. We are doing the data processing, applying clustering algorithms, and calculate the accuracy, select the one with highest silhouette score, and then scheduling the vehicles. Similarly, this can be extended to this can be adopted to other number of community or villages that can effectively save the time of villages and reduce the fuel cost, and which can also have a better conditions for the transport providers. and it can also use maximum utilization of the vehicles that are being used. Thank you.